guys, today we're going to be talking about molar mass. So we've already kind of introduced what the mole is to you. Remember that a mole is kind of like a dozen. You can have a dozen of something, which is 12, or you can have a mole of something, which is Avogadro's number. So 6.02 times 10 to the 23rd of that substance, whether it be 6.02 times 10 to the 23rd atoms, particles, ions, formula units, molecules, right? So it's similar to a dozen, but it's much larger. We're going to be calculating molar mass today, and so the molar mass, when we're talking about calculating this, is the mass of 1 mole of a substance. So the mass of 6.02 times 10 to the 23rd particles of a substance. When we're talking about molar mass, we like to think of it also as the number of grams per 1 mole. Right, so the number of grams per 1 mole. The molar mass of any element is equal to its atomic mass. So remember that we've seen on the periodic table atomic masses. That's the mass that we've been working with from the periodic table. But instead of AMU being the unit for molar mass is grams per mole. And we abbreviate that G over MOL. I know it's not a huge abbreviation for mole, but G over MOL. So not AMU, grams per mole. Right, so when we're calculating this from the periodic table, it's actually quite simple. We know from the periodic table, from what we've seen, that 1 atom of iron, right, we're looking at iron right there, is 55.85 AMU. So 1 atom of iron is 55.85 AMU. The molar mass of iron is the same number, but the unit is going to be different. It's going to be grams per mole. Now, if we break that down and kind of add all of this together, we know that 1 mole of iron is equal to Avogadro's number in atoms, so 6.02 times 10 to the 23rd atoms. 1 mole of iron is also equal to 55.85 grams. All right, now the reason I'm not putting grams per mole here is because we're already talking about the 1 mole. So it's 55.85 grams per 1 mole versus the molar mass being 55.85 grams per mole, right? So if the 1 mole is not included here, then we need to make sure that we're including it in that unit. And when we're actually using the periodic table, we're going to make sure that we're rounding to the hundredths place. Your periodic tables that we've given you already do that.
Sorry, one second before we go on. This is actually really important to try and process and understand, because when we start doing dimensional analysis next week, you need to be able to start coming up with these, what we call equivalent statements, on your own. So please ask us in class if the relationship between number of particles and grams and AMU does not make sense, because we're going to be starting to use that next week. Okay, so we're just going to practice a few problems calculating the molar mass. Now, the first one we're going to do is zinc. And we actually, is that not on there?
Put it on the.
Okay. Okay. So the first one up here is actually zinc. So remember, 1 mole of zinc is equal to 6.02 times 10 to the 23rd watts. What is our representative particle of zinc? It's just alone by itself. So we're going to have actually atoms. And remember, again, this is our Avogadro's number right there. We're going to be using it a lot. So that many atoms of zinc has a mass of,
look on the periodic table.
Look on your periodic table, and it's 63.99.
65.39.
65.39 grams. Remember, because for every 1 mole of zinc, that's how many grams, how much mass there is. Okay. Our second example, we actually have to do some calculations, because we're not looking at just a specific element in one type of atom. We are actually looking at a whole entire molecule. So that is going to be our representative particle for water. 1 mole of water is equal to 6.02 times 10 to the 23rd molecules of water. Remember that this is a covalent compound, H2O, right? So this is molecule for our representative particle. Okay, so again, our 1 mole of water, just like a dozen of something has 12 cookies, or a dozen cookies is going to have 12 cookies in it, we are going to have 1 mole of water having 6.0 molecules of water. And the mass of that is going to be our mass of hydrogen times 2. It's very similar to how we calculated the average atomic mass using the periodic table. So 2 hydrogens, 1 oxygen molecule, which has a mass of 16.00. We add that together, and we get 18.02 grams. So that, again, is our mass of 1 mole of water.
Remember when you're adding these together, right, we're adding, so when we're looking at thinking sig figs, we're actually looking at the least number of decimal places. They both have 2 decimal places, so your molar mass will always have 2 decimal places.
Which you can remember that because that's as far as it goes on the periodic table. Okay, our last example is to actually calculate, not just fill in some of these blanks, but calculate the molar mass of sodium chloride. Now, in this situation, you're not exactly being asked what the representative particle is, but again, we're going to be using that a lot next week. So the representative particle of sodium chloride is not a molecule, it's not an atom. We have a metal and a nonmetal coming together, so it's actually going to be a formula unit because it's an ionic compound.
Remember, sodium's right here, chlorine's right there.
It's an ionic compound. Formula unit is our representative particle. So to calculate the molar mass of sodium chloride, we are going to, you can if you want. We are going to first figure out what our sodium chloride looks like. So sodium is going to have a charge of +1.
Oh.
Yeah, 1 plus, and then chloride minus. If we crisscross and reduce, we know that our sodium chloride is NaCl. Great. So one of each. So first we're going to end up having we're going to write sodium. And we have 1 sodium, and our molar mass, or our mass is going to be 22.99 grams per mole. Now we're using grams per mole here because it's asking to calculate the molar mass specifically. Then we have chlorine, one of those also, 35.44 according to our periodic tables. 4.5, my bad, 4.5 grams per mole. And if we add those together, we are going to get 58.44 grams per mole. And that would be our answer that we would end up boxing. That's all we have for you guys today. We're going to do some of this practice and then be moving on to other stuff. So,
thanks for watching.